So using direct and inverse proportion, there are some easier questions which are typically grade 5. These are the ones that are typically grade 7. We can write y is directly proportional to x as either y is directly proportional to x, or we can write it as y equals certain constant, because if we draw it on an axis where that's our y and that's our x, the line like this will show a direct proportionality. There's no x squared going on here. It is like the line y equals mx plus c, where c is 0. So we're going through the origin of the line. So this is a graph of y when it's directly proportional to x. When it's inversely proportional, we're talking about the reciprocal, and therefore we can say y equals some constant. We don't know what it is, like this gradient here. We don't know what it is, but we do know that it's multiplied by 1 over x, which also means we could write it like this. So y is inversely proportional. And what that looks like, the graph of y equals 1 over x, for instance, is a graph that looks like this. If we think about it, when x is 0, there is no, you cannot divide anything by 0. So we are not going through the origin. Okay, we are not going through the origin. As x increases, y gets smaller. And so actually what we're looking at is a curve that does this. Think about it as a negative. As x gets bigger, y gets smaller, but y will be negative. So if x is negative, then y will also be negative. And therefore this is the graph, because this is in the positive quadrant and this is in the negative quadrant. Y is directly proportional to x squared. This is how we write it. And the graph is going to look like this. Because we've got y equals x squared, it can have a gradient here, but we know that an x squared, a quadratic graph, has this sort of curve here. And that's when it's proportional to x. And this one is similar to this one in nature, except because it's squared, if x is negative, y will always be positive. So we're looking at a graph that is always positive in the y-axis. So the y-axis is always going to be positive for this graph here. So if you use that information and we look at this here, we have to work out, bring it out a bit, which is which graph. So just see if you can remember which one is which. And then I'm going to just bring it out. Y is directly proportional to x. The graph is A. Y is inversely proportional to x. We're looking at this here because we have a negative and a positive. Directly proportional, and we're looking at the graph of y equals x squared, and that's C. And then y is inversely proportional to x squared, and it's the one that's left over, which is the one that's both on the top. So this question, A is directly proportional to B. So we can write A is directly proportional to B, or we could write it as A equals a constant something multiplied by B. We don't know what that is. We can see automatically that when A is 7, B is 28. So K doesn't disappear. It's not a 1. But what we want to do first is we want to find K. So step 1 is to find what is K. So we substitute in. We take that A and we put it as a 7. We take that B, which is our 28. And then we divide both sides by 28. And therefore we have 7 over 28, which equals our K. Now that will actually simplify 1 over 4. Then what we do is we use this equation and we substitute this K back into this equation. So where K equals a quarter, A equals a quarter B. We need to find the value of B when A equals 5. So 5 equals a quarter of B. I'm actually going to write that as B over 4, because then I know I can multiply by 4. B is 20, and that's our answer. Let's do an inversely proportional example. So C is inversely proportional to D. So I'm going to put my constant at the top here, and then I'm going to write D, which I can also write as C equals K over D. I know what C is, and I know what D is. C is 3. D is 8. And therefore K multiply them by 2 gives us 3 multiplied by 8 is 24. So we know what K is. So then we're going to substitute K back into here. We know what C is. Sorry, we know what D is, and we need to find C. And that's our answer. A couple of more examples. E equals 3. F equals 36. So we know what K is. So we're going back to E equals KF, which we can also write as F over 12. We then know that E is 4, so we put that into here. 4 equals F over 12. We're then going to multiply both sides by 12, 48. Oh, we haven't seen this before. G is directly proportional to the square root of H. So that says G is directly proportional to the square root of H. And it's directly proportional. So there's no 1 over. And so we just put the constant here. We know that G, when G is 18, H is 16, which is nice because it's square roots. Yeah. 18 divided by 4 is the same as 9 divided by 2, which is the same as 4.5. You can leave it as a fraction or as a decimal to choose. It says find the possible values of H when G equals 2. Now that's interesting because it says possible values, and we'll see how that works. So we're going to substitute back into this. G equals K, which is 4.5 or 9/2, multiplied by the square root of H. So we've just substituted K back in here. If G is 2, so what we're going to do here is we're going to divide. Well, we can do it in 2 stages. We can divide by 9 and then we can multiply by 2. It's also the same as dividing by 9/2. What we're doing is we're dividing by the 9, which puts the 9 here, and we're multiplying by the 2. 2 times 2 is 4. Now, if we square, we're looking for, if we square both sides here, square root of H. So we're going to square both sides to get H. This is going to be 16. This is going to be 81. But it could also be, this H could be negative. Is that right? I think we're also looking at negative 16 divided by 81. I might be wrong, but that's what I think. It says possible values, and this is a possible value. I'll have a think about that one. Maybe. But this is the answer that we're going to put on the answer line. And then the final one. The table shows pairs of value for X and Y. Tick the correct statement below. So we've got these proportionality statements here. Which one is correct if we're looking at this? So we're going to try them. Do we have the same K for both arrangements? This one is Y is proportional to X. This is that one here. So Y is proportional to X. So if Y is 32, X is 2, K is going to be 16. Okay, so for the first one, K is 16. I'm going to try it again. This time substituting in these two. 72 equals K is 3. 72 divided by 3. What are we doing? It goes in twice, 1 left over, 24. So K is 24 here, K is 16 here. So this is not. Okay, so I'm just going to cross it. It says tick the correct statement. So I'm just going to put a cross there because we've tried it and it's not working. So Y is proportional to X squared. Let's substitute in again. Y is 32. Okay, X squared. Now X squared, we'll put it in as 2. And we're going to try that again with the second one. Aha, we have found a relationship. Both of those K's are the same, so therefore this is the same. Because the relationship is correct here, it is not going to be correct here, so we're going to leave that one as it is. So we've just got one tick. In the answer, you do only need to put that one tick in place. You don't need to put the crosses, but I wanted to show you why we put the crosses. And then it says write a formula in terms of X. So we know what K is. We've worked out what K is. So we substitute the K in this formula. So I'm just going to write the formula here. but we know that k is 8, so it's y equals 8x squared.